or subscribers or whatever they're called. $22. Have you noticed that I'm putting little thumbnails and little pictures on my videos now? That's kind of fun. Just kind of trying to have a little bit of fun here. I don't know. Okay. So let's make sure my video's going. Yes, it is. Okay. First thing, you guys are starting to get it figured out, but I want to emphasize that if you do not understand everything on this sheet and you know you got one wrong and you're not asking it, I don't think you're being a good student. Or let's put it this way, I think you can be a better student. Okay? I think that's a critical part of anything. If you got something wrong, you need to figure out why. Fast forward 15 years down the road, you got a job, and you're like, okay, this project didn't go like I wanted it to. The first thing you better ask is why. Okay? If I've got something at home, like my wife's upset, I'm going to ask out, okay, what did I do wrong? And what do they say, guys? Nothing. It's fine. No, my wife and I communicate really well, actually. But no, you should always, a good student always strives for understanding and doing things correctly. So, unglue your hand from the desk, ask questions. Nobody's going to look down on you for asking a question. I will actually look down on you if you don't. Because I hate getting to quizzes and I think everything's going fine because nobody's asking questions and then suddenly people can't craft a line. Okay, but anyway. Do you have any questions on this before we go to the other worksheet?
54.
54. Thank you, sir. 54 is a very, very, very important thing because that's exactly the format I'm going to do it tomorrow. Exactly the format. I'm going to give you an equation and you're going to have to tell me, what does the plus 5 do? What does the minus 1 do? What does the 3 do? What does the negative do? You have to tell me on all those things. Okay, so all of these, the plus 5, it's on the inside, so it's going to be a horizontal shift. How do we know it's a shift, not a stretch? Because it's plus or minus. Stretches are multiplying. Okay? This one, plus 5, it's the opposite of what you think, so it's going to be minus 5. It's going to slide it to the right. Or, I'm sorry, to the left, the opposite. So it's going to slide it to the minus 5, which will be left. Okay? This minus 1, that's outside, so it's not horizontal. That only leaves vertical. It's going to go down 1, because outside does exactly what you would think. It's going to move everything down 1. The negative on the outside is going to be a vertical flip, because it's outside. That's going to cause a vertical change. And the times 3 is going to be stretching it 3 times vertically. You can go several different you can say this several different ways. Like if you said 3 times taller, that's fine. Instead of vertical stretch times 3. As long as you can communicate to me what's going on. Okay? Does that help, Ethan?
Yeah. So if it was just positive 3 outside, it'd be a horizontal flip.
If this was positive, there would be no flip. The only time you have flips is if there's negative. If my x has been made negative inside, it's going to be a horizontal flip. If there's a negative outside, it's going to be a vertical flip. If there's no negatives, no flippy. Okay? And one thing I want to emphasize, this is probably a good time to emphasize this, and I know I've talked about this before, but the reason we're talking about this is this works for every function on the planet. It's not just squares. It's not just absolute values. It's every function on the planet. So if I'm dealing with, say, a growth of something that uses an exponential, if I need to slide it, shift it, stretch it, I'm going to do these exact things. And I know I've talked about this before, but if I've got a situation that needs to be matched like this, I'll talk about it just a little bit more specifically. My original sine function is the the purple one here. If I want to talk about this real world situation, might be a tide, might be a temperature, might be, a sound wave or something like that, I've got to modify this function to where it gets there. So I would have to move it over, move it up, stretch it vertically, maybe flip it, and then get it for the important points to be where I want them to be. So here's what I'm saying is, this is not just an x squared situation. It's not just an absolute value situation. Every function you use from here is going to be using these same things. So it's worth learning and learning well, because you'll use them later on. Okay? When we really start getting to what the mathematics that I truly enjoy, applications, then all these things are going to come back to be in favor. Anything else from this page? 12. Okay. So on 12. 12. Okay, let's see. Where can I find this? Where am I at here? Okay. So the first one that has a negative on the outside, I don't care where the negative's at. This one's going to be a flip. And this one's a vertical flip. So that's a reflection. Flip and reflection, same thing. Actually, this one could have parentheses, could not have parentheses. It doesn't matter. So like say in the last one I was dealing with, this one, that has a reflection. So even though there was a grouping symbol with the absolute value, it still has a flip or a reflection. Okay? So it's the presence of a multiplication by a negative in some way, shape, or form. That's what causes it. Okay? This one here, that is a dilation because it's either being stretched or shrunk. More specifically, what's happening to this one? The 3, it's on the inside, so what's happening? Opposite is a horizontal or vertical. Horizontal. So it's going to be horizontally. Times 3 makes you think it's going to be stretched, but no. It's going to be shrunked. 1/3 is what it was before. So that is a dilation. Where I go, that's a dilation. Okay? And this last one, a -4, well, what is that one going to do? Is it horizontal or vertical, the -4? Hortivertical? Vertizontal? It's horizontal. Because it's inside. What's the restaurant? IHOP. Inside. Horizontal. Going to cause opposite change to what it looks like. This one's going to be a slide to the right. So that is a translation. Okay? So right now, if I move you from one desk to another, that's just a translation. If I move you from one desk to another and say, sit on your head, there's your flip. Okay? If I stretch you to where you're twice as long as you are now, and that painful thing they used to do back in the dark ages, well, there would be your dilation. You ever heard of the term drawn and quartered? That's where they put ropes on both your arms, or your hands, and ropes on both your ankles. Tie the other end of the rope to horses, and tell the horses, go. Sounds painful, doesn't it? Yeah. I'm glad we live in the days we do, even though there are some mess up things still going on. Okay? Anything else? A horizontal dilation. Yes, I will. And actually, I'm going to take advantage of this opportunity to talk about the horizontal dilation found on this other worksheet. Right here. Thank you very much. So this one, this times 2, the orange, I'm trying to sit right here because I get too far away from my microphone. The orange was my original parent function. Okay? So my parent function really wasn't wide, really wasn't thin, but this one, the times 2, that's on the inside, it looks like it's going to be twice as wide, but it's actually going to be the reciprocal of that. It's going to be half as wide. So we'll notice that my orange point from my center line was originally out 1. And now it's just going to be half as wide. It's only out a half. My orange point was out 2. Now it's going to be half as wide. It's going to be in by 1 instead of 2. So everything got squeezed in. So there's an example of a horizontal dilation.
And what makes the
Because the 2 is inside the parentheses. And it's not a +2, -2. Those are slides. The times 2, we'll get the same results by plugging in smaller x's, so it actually shrinks it down. You guys are asking some good questions. Okay, the rest of this, let's go ahead and zoom out so you can see the rest of this, and you guys compare the work you did last night. Okay, check that. And I will check my email while you're doing that, because I need to do that every once in a while. Absence report, garage door. Okay, I think we're good to go. Lunch today, breaded beef patty, mashed potatoes, gravy, carrots, dinner roll. Ooh, that sounds kind of good, really. No, I brought my own hamburger patty with rice and corn. Yay. No gravy. I love gravy. Molly, did you golf again yesterday? Oh, okay, so this result is from a couple days ago. You're 90, you're third place. Okay. Oh, so that part didn't get updated. I got you. Okay. Okay. Boy, you think I'm going to ask you to do all this tomorrow? Yeah.
Can we go to the bottom? Yeah.
The bottom 2? There's 3 on the bottom.
No, not that one. The middle one and the middle one in the right.
Okay. So the piecewise functions. Okay. Okay, so let's take a look at this. First of all, this one right here. Again, I think it's going to be helpful for you if you do your divider line and say over here on the left, I'm doing the -2x plus 1. And on the right, I'm doing 1/2 x minus 3. Okay? That's just getting me organized. Then I don't have to look up and down here all the time necessarily. So I know this is going to be a line. I know this is going to be a line. Let's find out where the line ends. That's what I like to do. So this -2, plug it in. So if I plug in -2, -2 times -2 gives me 4, plus 1 gives me 5. So that's where this point comes from. So that's my ending point. That just comes from plugging in, finding out where is it there. So then -2 is my slope. So I could plug in -3, I could plug in -4, but let's use our knowledge. Up 2 over 1, up 2 over 1, up 2 over 1, so it's coming downhill to that point. And if I would let this go, it looks like it would hit right there at 1. Is that a surprise? No. Because it says my y-intercept would be 1. So if you've done your work right, and your slope is -2, and you continue it, it's going to hit at 1. Or, yeah, 1 in this case. On the other side, here we have I'm just moving over to my 1/2 x minus 3, so I'm going to plug in -2. Plug in -2, I get -4. Solid, and then I'm just going to use my slope. Well, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and my y-intercept is -3. Okay. This last part. Don't make it too hard. For a line right now, we need, gotta stay where this can hear me. We need a slope and we need an intercept. That's it. We need a slope and an intercept. Okay? So on this middle part, I think the middle part's the easiest. Find my slope, find my intercept. My slope, up 1 over 2, up 1 over 2, up 1 over 2. My slope's 1/2. My y-intercept is 2. There's my plus 2. You can all do that. And hopefully not have to reach too much into your power reserves to do that. It's just slope and intercept. The next parts, you should be able to get your slope pretty easily, I would think. This one right here, negative x. How do I know it's negative x? Because here I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. My slope's negative 1. And if I follow this backwards to where it would hit my y-axis, we're going to throw algebra in here pretty quick to find your y-intercept a little bit more rock solid. But this one, let's just focus on slope and intercept. If I continue and do that, it's going to hit at 9. That's where my plus 9 comes from. This one, I'm up 3 over 2. Well, so there's my slope, 3/2. And then if I continue that, up 3 over 2, up 3 over 2, it's going to hit at 9 also. So that's where my plus 9 comes from there. And all these over here is just where does it do what? Less than 4, it does that. Between negative 4 and 2, it does that. Greater than 2, it does that. Okay? That's why we spent so much time making sure you understood what slope was. And doing the slope-intercept stuff, because it's used all the time. Okay, anything else before we go to whiteboard review? This forces me to pause. A good teaching strategy of pause. Grab whiteboards. Nuts. Okay. So before we even get to that, you don't have to have, keep your caps on your pens. I don't want us to get all high from pen fumes. I'm not somebody who really believes in review sheets because in college they won't give you review sheets, so you need to be able to review for something yourself. Okay? So today we're actually going to just talk about how to review, how to get ready. Okay? First question I want to ask you is, how many of you have ever taken notes in a class and never, ever looked at those notes? Raise your hand. Okay? First of all, I don't think it was a waste of time, because what they say is, I'm going to draw this so those at home can partly, see. if we're looking at this as a baseline, and things go up from here, if you hear something, you're this likely to remember it. If you type it on a computer, you're this likely to remember it. If you write it out by hand, you're this likely to remember it. If you teach somebody else how to do a skill, you're like this likely to remember it. Okay? So the idea of writing out notes, even though you never use them necessarily, is not worthless. It helps you remember stuff. But I would argue that one of the reasons why you never look back at your notes is because of review sheets and stuff. People, right before a test, say, here's what's going to be on the test. Okay? Where, in my opinion, we need to be able to study for things without being told, here's exactly what's going to be on it. Or remember how to do this. Because here's what you should be able to do. This is over sections 1.4 to 1.7. You don't have to get your textbook out, but I'm just gonna do show you what I think you should. Is that as wide as it gets? I think it is. Okay? I'm just going to show you what I would do if I were you to study. I'd go section 1.4. Okay, here I am in section 1.4. What was that about? Sketching graphs and comparing functions. Okay, so we need to be able to draw graphs. Okay, and I'll give you an example, like this one right here. This is a better example. I'm just looking at the examples in the book. That's all I'm doing. Okay, this one where they give us the description and we draw a picture. You remember doing those?
Yeah.
Yeah. We did like 10 of them. Okay? So that's something you need to be able to do. Let's practice it on one of them, and then we'll see how you do. Let's do number 6. So you need to be able to understand what an x-intercept is, what a y-intercept is, whether it's linear or not, what continuity means. Continuity means you're not going to lift up your pencil, you're just going to draw it. When it's positive, when it's negative. When it's positive, it's above the x-axis. When it's negative, it's below the x-axis. When it's increasing and decreasing, go ahead and give us a sketch of that, please. This is exactly what I'm going to ask you to do on the test. I'm going to give you some descriptions, and you're going to draw me something. And show me when you're done. Okay? Okay? Good? Okay? Ooh, I like yours. There's a reason why. Can I have yours? It's closer, so I don't have to walk so far. Perfect. Ooh, yours is even curvier. I like it. Okay? Start with your x-intercepts and your y-intercept, and then sketch it out. Okay? Good job? Okay? So here's what we have. Okay? I know. So this is good. Now let's take a look at all of the criteria. Okay? It says it has x-intercept and a y-intercept. It says it has a minimum right here, minimum of 4 at x equals 0. Or negative 4 at x equals 0. It says it was decreasing when x was less than 0. It says increasing for x is greater than 0. It says that when my x's were positive, my y's got more positive for my end behavior. When x's got more negative, that my y's got more positive. Okay? I'm going to ask you a little bit of advanced question. See how you think about this one. Is that a parabola?
No.
It's not. Why not? Because what? The vertex is not in the middle. A parabola is always symmetric about a main diagonal, and that main diagonal is set by your vertex. So no, this is technically not a parabola, but it's all right. Okay. Here we go. Correct. 1.4 to 1.7. That's exactly what you need to know. Boom. Here we go. Yeah, how would you greet them every day? Hey, hey! Sketch it. Hey, Steph's driving a car she's thinking of buying. She decides to accelerate to 60 miles per hour and then decelerate to stop it. To test both her acceleration and her brakes. Okay. Okay. Who's going to give me the best graph? That's what I'm looking for. Who's going to give me the best graph? Time always goes on your horizontal axis. That's worth walking for. Show me what you got. No, Chase is going to battle Zach here in the best graph category. But I've already walked all the way over to Zach. Mm. 15 seconds to accelerate all the way to 60, and then they're going to stop. Good. Very nice. Very nice. Okay? So here's what we're going to do. We're just going to show this. Okay, the thing I like about this one is he labeled things. It's not the neatest, but he labeled things. And I don't know where he came up with it, 5, 10, 15, 20, 28, and then 30. What? That's a 5? Okay, anyway, I'm just giving you crap. Okay? So this one, technically, I don't know if it would be straight in the real world, but I understand most of you guys are going to do that. But yeah, labeling some units as far as time and speed would probably be wise. Okay? So let's pass that back over to him. Thank you. Yeah, I know. I'm feeling violent today. And again, this is all guided by just flipping through your book. If I was like, oh, crap, I'm not good at this stuff, I would try number 5 or number 7. And where are those answers at? In the back of the book or your homework. The one thing that's awful about this book is they don't have any review problems for me to assign. So you're going to have to lean on your past assignments and such like that. Okay. The next one. The next section is about graphing linear equations and inequalities. So graphing lines and shading. Okay? So here we go. Grab it. Your y-intercept is incorrect. That's a better. Perfect. Nice job. Perfect. Beautiful. Your x and y intercepts are incorrect. I'm sorry to tell you. Extend it out. Very good. And almost perfectly straight. Did you draw that with a ruler?
No.
Because it looks like you drew that with a ruler. That is like freaky straight. That is perfect. It's just awful. Very nice. Your x-intercept is incorrect. Okay, by far the easiest way is to use your intercepts. Here my y-intercept is -6 because if I divide both sides by my y-intercept is +6. If I divide both sides by a -2, I get +6. 1, 2, 3, 4, 5, 6. Okay, and if I divide by 3, I get a -4 from my x-intercept. 2, 3, 4, and then we're going to go ahead and get that line right there. How do I know I don't shade? Doesn't have a greater than or less than, so no shading necessary. Here we go. Let's see how much I can zoom in here. Sorry. Close, but no cigar. So something's wrong. No offense, but everything's wrong with that one. Your slope's wrong, your y-intercept is wrong. No offense, I'm just trying to communicate. Come on, you guys should be showing me some graphs by now. Yes. Nice job. No, you're farther away from the answer than you were before. No, you're okay. Just hold it up there. So you got -4y, so -4. My y-intercept is, it should be, you got to subtract 12 from both sides, not add 12. Your line is right, your line is right, but something else is wrong. Something's wrong with your line, dude. Something's wrong with your line. So one person has this right so far. Something's wrong with your line. Something's wrong with your line. Your x and y intercepts are there, but something's wrong with your line. Something's wrong with your line. Yay! No yay. Okay, so here we go. We got some work to do here, folks. You guys have you need to put the lid on your brain so this doesn't all fall out. Okay? So this one I could put it in standard form, and then I could go ahead and find my intercepts. That's one way I could do this. I could find my x-intercept to be 12, and my y-intercept to be 3, and then it's going to be a dotted line because it's greater than, and then 0, 0. If I plug 0, 0 back in even to my original, I get 12 is greater than 0, which is true. So we're going to shade down. Okay? So that is easier than getting y by itself, but I know a lot of you guys tried to do y by itself. So here's y by itself. Okay. I subtracted my 12 from both sides. I divided everything by a -4. I had to flip my inequality because I divided by a negative. So y is less than -1/4 x plus 3. Down 1/4. Dotted. Y is less than, or go back up here and use a test point. If you go back up there and use a test point, it'll avoid any mistakes you may have made. So, woo! That needs to be better. Ugh. Okay, let's try another one. -1/2 x plus y. Let's go is greater than or equal to -2. This one you can get y by itself pretty easy. You can get your intercepts okay. Whichever way you're most comfortable with. It doesn't matter. Your x-intercept is incorrect. Good. I was just trying to put on my zooming eyes there for a second. Your x-intercept is incorrect. Perfect. Perfect. Yeah, some people think that the x-intercept is 1, but it's not, because 1/2 of 1 doesn't give me 2. 1/2 of what gives me 2? That's an entirely different ballgame. Don't forget to shade. Your line is perfect. Your x-intercept is incorrect. You're shading wrong. Your information up top is right, but you didn't plot it on your points right. I just don't like it. Good. I'm just saying I can't say one specific thing is wrong. Good, good. Okay, so here we go. Let's unfreeze. Yeah, I looked at yours. I said good, good, good. No, sorry. No, you're good. I can tell from here. You're perfect. What else would you expect? Here we go. So this one, I did it one of two ways. My y-intercept is -2, and my x-intercept is actually actually 4. -1/2 of 4 gives me -2. And then I graphed it. 0, 0 does work. 0 is greater than or equal to -2. Okay? Or you get y by itself, and I end up with a -2 for my y-intercept. Up 1/2, up 1/2. We get that same thing. That's something we should be able to graph. Okay. Now, caps on your pens for a little bit. Even on mine. Okay. Special functions. Your favorite. piecewise functions. We've worked on this a lot. So this will test to see how good a students you've been in the past, whether or not you're asking questions when you got them and all that good stuff. Here you go. Grab it. I made it, didn't I, Jay? Yeah, I made it. Yeah, I made it. Of course, people make fun of me when I miss, but they never applaud when I make it. It's a hard job. And people laugh at me when I cry. No, it's a piecewise function. There should be two different parts to your graph. Oh. Neither one of your points that start your lines are correct. Perfect. You're ready to kick butt on this thing, aren't you? You've been working hard this last week. Right side and left side. You can't ever have two above one another. Then it wouldn't be a function. No, they can't cross. Open circle. Where's your open circle? The rest is perfect. Open circle. Where's your open circle? Are you just guessing where your open circle goes? Yay! But I'd like to see enough points where I know your top one has the right slope. Okay, your left one should come all the way to your line, to your vertical line. Should come all the way over. Okay. And your right one, the starting point is incorrect. Perfect. Perfect. Open circle. Close circle. Okay. Some of you guys got some work to do. Some of you guys have got some work to do. Your height on your right side isn't right. Okay. So here we go. Boom. Okay. On the right, first of all, let's put it on our axis. It cuts at 1. On the left side is x minus 3. On the right side is 2x. How do we know where to start? Plug in 1 into, this is x equals 1 right here, that line. Plug in 1 there, and I get negative 2. And my slope is 1. So down 1 over 1, down 1 over 1, down 1 over 1. My slope is 1. Don't make that too hard. It's just plug it in, find out where do I start, and then where do I go from there. And look at this. My y-intercept is negative 3. My y-intercept is negative 3. Okay? Other side, let's plug in 1. And I get 2, so that's why I started up at 2. And then from there, my slope is 2. Up 2 over 1. Up 2 over 1. Up 2 over 1. Okay? For doing 2 of them probably about 4 days in a row, I thought that would be better. I hope it's better tomorrow. Okay. That's going to be our last one, so go ahead and put your whiteboards away, please. Okay. You do have something to do tonight for me. EOS. I've not done this before. I'm doing this for the first time, trying it, because there's really not a lot of review material to choose from. Evidence of studying. I want to see, starting with a fresh sheet, that there's evidence that you've studied. Okay? So take out a fresh sheet, do some odds, look at some problems from assignments. Show me that you've spent 20 or 30 minutes either writing down the important stuff, whatever. So you're gonna interpret that however you want. But who knows? Maybe that would even be worth some points on your quiz. Who knows? Evidence of studying for 20 or 30 minutes. Let's take out
Just like
yeah. So you can do some odds from whatever section. And do it, check it in the back, do it, check in the back, or, even some stuff from worksheets, to regraph it or something like that. But yeah, that's your job. Study. That is your job. Okay. And that is it. Let me stop this recording. Be ready to go tomorrow. Yes, we will have a review in the morning.